Okay guys, so this is trans fats, and this is why they're basically well harsh on you. Before we can talk about that, we have to do a little bit of prep work on stereoisomers, because they're involved in the discussion. So up here I've drawn my two different stereoisomers. We've got a lack of rotation around my carbon-to-carbon double bond, and two different groups on each carbon, so these are stereoisomers. And what we've got is our cis or Z isomer, where both the R groups point in the same direction, and our trans or E isomer, where they point in opposite directions. If you've got a bit of trouble remembering how they pair up, I always think Eddie Izzard, the comedian, is a transvestite. So that helps it keep in my head. By process of elimination, cis and Z must go together. So do try and remember that throughout this little demo, otherwise you'll get a bit lost. Cis in the same direction, trans in opposite. So I'm going to draw for you a structure of a fat molecule. We have propan, 1, 2, 3 triol. This looks like that, and obviously you're going to have your extra H's on. And what that does is it reacts with 3 fatty acids, which are basically carboxylic acids with a very long chain of carbons coming off it. So this is going to react, we're going to get in a sterification reaction, water is going to be given off, and we're going to get 3 of these. Just so I don't mess up all my space on my board and it doesn't look too confusing, I'm only going to draw 1 carbon tail, but in reality all 3 of these would have carbon tails. And the carbon tails can be exactly the same, in which case we call it a simple fat, or they can be different to each other, in which case it's called a natural fat, or a natural triglyceride. So I'm just going to draw my top one, and let's say, I'm just going to draw the rest like this. Let's say my top one has a trans double bond. It would look like this. So I've got one bond going one way and the other going the other way. So my trans bond, when I have a trans fat, that's what it's called, trans fat, because your double bonds are in the trans orientation, tends to be in straight lines. Now what this means, because it's in straight lines, is it's quite a flat molecule. So because it's a flat molecule, they can pack together very closely. Now, when molecules can pack closer together, the van der Waals forces between them are stronger. So these trans fats have very strong van der Waals forces. And this, as I'm sure you remember from last year, will increase the melting point. So these tend to stay as solids very easily. They tend to solidify very easily. Now let's have a look at our cis fat. So I've got both my bonds going in the same direction, and because of this we get kind of like a kink in the molecule. So now, rather than being able to pack very close together, because our molecule has a kink in it, they can't pack very close at all. So the van der Waals forces are a lot weaker, and it's a lot easier to melt it into a liquid. It will have a lower melting point. Now you might think that this is bad, but in fact it's quite good, because what it means is cis fats tend to stay as liquids in our blood. So they can travel around our blood and probably go to our hips or our ass, although not in my case as I don't have one. However, trans fats, because trans fats can pack together and have a very much higher melting point because there's stronger van der Waals forces, they solidify a lot easier. So if I have an artery, what's going to happen is I'm going to get a big clump of trans fats stuck blocking my artery. Now imagine your heart's trying to pump blood through here. Because it's a narrower space, it's going to be a lot harder to do it, which is why fat people get really knackered after about 2 minutes jogging, if you ever see fat people jogging. Over time, this will build up and build up and build up, and it can, if you get it bad enough, actually almost completely block it, and then what happens is you get a blood clot, you get a heart attack, and you die. Heart disease is the biggest killer in the UK. Even more than cancer, it's the biggest killer. The main cause of heart disease is this. So this is what kills more people than cancer every year in England. Really, really dangerous for this to happen. But this isn't the whole story. It's not just that trans fats solidify and block our arteries, they also, for another reason, cause our arteries to get blocked even more. And that's because of these things called lipoproteins. Okay, two types of lipoproteins. We have high density and low density lipoproteins. Now, high density lipoproteins are the good lipoproteins. What they do is they take this congealed, solidified fat and they remove it and stick it back in our ass or our hips. So they're good. Low density lipoproteins, they're the bad ones. What they do is they take it from our ass and our hips and they stick it back in our blood. So you've got two almost warring types of lipoproteins. They work against each other. What trans fats do is they increase the amount of low density lipoproteins you have and they decrease the amount of high density lipoproteins. So not only is more fat getting stuck in your blood, solidified there, but your body is less able to remove it and more is getting put there anyway. So they've got this twofold effect for why they proper mess you up. And that is why trans fats are bad. Eat salads.